20 pounds of candy that sells for 66 cents per pound must be mixed with candy that sells for $1.22 per pound to obtain a 7-pound mixture that sells for 93 cents per pound. Let's call X the number of pounds of the 66-cent candy. And Y, the number of pounds of the $1.22 candy. Those two have to total up to 7 pounds. Notice that I am adding things that have the same units. Pounds plus pounds is more pounds. On the other hand, to get the second equation, I'm going to use the fact that the number of pounds times the price per pound, price in dollars, is going to give us dollars. I have to apply that for all three types of candy. 66 cents per pound, or $0.66, times X pounds of that, plus 1.22 times Y as well. And then on the other side, I cannot forget to have the 0.93 multiplied to the 7 pounds of it, so that I'm getting dollars plus dollars equals more dollars. Whereas I've heard lately, more money is more problems. All right, so we've got two equations here. Let me simplify 0.93 times 7, first of all. Yep, 6.51. If we take the first equation and rewrite that, let's subtract y from both sides. I can do substitution. Distribute. 0.66 times 7, whatever that is, I'd expect that to be similar to 6.51. Similar size, and it is 4.62. Don't forget to distribute to the y term as well. So that's two things so far. Don't forget, when you do price per pound times number of pounds, to get the number of dollars you'll have, you need to do that in 3 places here, then also distributing. Okay, notice also how my solving for x instead of y means that when I combine the y terms here, I'm going to have a positive coefficient. Subtracting 4.62 from 6.51. Getting 1.89. Dividing that by the 0.56. I'm getting 3.375. That would be 3.375 pounds of the $1.22 per pound candy. Plugging that in over here to solve for x, we'd have 3.625 pounds of the 66 cents per pound candy. Couple of points here. Notice how these are pretty close, but X is a little bit larger. And that could have been expected right from the beginning, because the mixture's price of 93 cents, that is 27 cents away from the 66 cents per pound, while the price of the mixture is 29 cents away from the $1.22 per pound candy. So the mixture almost halfway in between in terms of price, but it leans just a little bit towards the cheaper amount. Makes sense. We're going to be using more of the cheaper candy. The other thing is you're going to be asked for some reason to round each of these to 2 decimal places. If I were to plug in right now into the equations I came up with, things would check out, but by rounding, you wouldn't get both sides exactly equal. Y would be about 3.38 pounds of the $1.22 candy, and X would be about 3.63 pounds of the 66 cent per pound candy.